Hi, I'm Gabe. For this problem, we're asked to solve the inequality 4x minus 1 divided by x is greater than 0. In order to begin solving our inequality, we need to find first the zeros of the inequality and then the undefined values of our inequality. To find the zeros, we'll set the numerator equal to 0 and solve for x. So we want to solve the equation 4x minus 1 equals 0, and we'll do so by adding 1 to both sides of the equation, leaving us with 4x equals 1, and then dividing by 4. So we end up with x is equal to 1/4. Next, we want to look for the undefined values. Now this happens when our denominator is equal to 0, and since our denominator is only x, our undefined value is when x equals 0. Now x equals 0 and x equals 1/4 become our key numbers. So our test intervals are the interval from -infinity to 0, the interval from 0 to 1/4, and the interval from 1/4 to infinity. Now what we'll want to do is we'll want to choose a test value from each of these intervals and substitute in to see if it satisfies the inequality. So choosing an x value from the interval from -infinity to 0, let's choose -1. So substituting -1 into our equation, we have 4 times -1 minus 1, all divided by -1. So this is -4 minus 1 is -5, divided by -1 is 5. So on this interval, from -infinity to 0, we are positive. On the interval from 0 to 1/4, again, we'll want to choose a test value. So let's choose the test value x equals 1/8. Substituting 1/8 in for x, we have 4 times 1/8 minus 1 divided by 1/8. This is equal to 8 times 4 times 1/8 minus 1, which is equal to 4 minus 8, which is -4. So on the interval from 0 to 1/4, our function is negative. And finally, we'll want to choose a test value on the interval from 1/4 to infinity. Let's choose x equals 1. So when we substitute this into our function, we have 4 times 1 minus 1 divided by 1, which is 4 minus 1, which is 3, divided by 1 is 3. So on the interval from 1/4 to infinity, we're positive. So since we want to know the values at which our function is greater than 0, we want to look for the intervals at which our function is positive. So that would be the interval from -infinity to 0 and from 1/4 to infinity. Now to sketch the graph of our solution, we'll draw a horizontal number line and label a few x values on the number line. 0, 1. Let's also label 1/2, 1/4, as well as 3/4. So since our solution is the two intervals where our function was positive, -infinity to 0 and 1/4 to infinity, we'll wish to include these in our graph of our solution. And because the inequality is strict, each of these will use parentheses instead of brackets. So the first interval was the interval from -infinity to 0, and on our number line, we'll place a parenthesis at 0, and we'll include all of the values to the left of 0. And since our next interval is the interval from 1/4 to infinity, we'll put a parenthesis at x equals 1/4 and include all of the values to the right of 1/4. Thank you.